The endothelial collapse, a tale of L5 invasion. The endothelial cell is a vibrant, busy city named cardia. It lines the blood vessels, ensuring smooth traffic flow for all the vital components of life. Maintaining the city's health requires constant upkeep, mostly handled by steady couriers bringing essential supplies from the bloodstream. Courier L1, the standard low-density lipoprotein, arrives daily. L1 holds critical lipids needed for the cell membrane and signaling. To gain entry, L1 keys into the specialized gate, the LDL receptor. It is a precise, regulated transaction, ensuring only necessary supplies enter. But sometimes, the environment outside becomes stressful. When L1 molecules are exposed to factors like high glucose or chronic inflammation, they become oxidized and shift their electric charge. They transform into L5, the highly electronegative damaged lipid particle. L5 can no longer use the standard LDLR gate. Instead, its frantic, charged energy triggers an emergency entrance, LOX1, lectin-like oxidized LDL receptor 1. LOX1 is not designed for gentle, routine intake. It's a quick response unit that lets the overwhelming distress signals flood the cell. Once inside, L5 doesn't deliver necessary goods, it delivers chaos. Its first target is the power grid, the mitochondrion. L5 particles corrupt the delicate internal structure of the mitochondrion, clogging its machinery and causing a buildup of toxic reactive oxygen species. This internal distress is mitochondrial dysfunction. The cell's essential energy supply drops critically, and the entire city of cardia slows down. But L5 is far from done. It moves swiftly onto the central manufacturing complex, the endoplasmic reticulum, ER. At the ER, L5 forces rapid, poor-quality production of proteins. The ER, designed for meticulous folding and quality control, becomes instantly overwhelmed by misfolded, useless structures. This sudden bottleneck is ER stress, and it triggers panic across the whole city's communication network. As the two great internal systems fail, power and production, the cell steward, cardia, knows the damage is irreversible. These cascading failures send a final, desperate alarm signal to the central archive and command center, the nucleus. L5's pervasive toxic effects now breach the protective walls of the nucleus. It starts tampering with the master code itself, disabling genes responsible for repair and growth, and causing fragmentation in the fundamental DNA structure. This final code disruption results in the last decree, senescence, forced biological retirement, followed quickly by apoptosis, programmed self-destruction. The once vital endothelial city of cardia collapses, leaving behind inflammation and damage, a tiny, tragic piece of the ongoing story of vascular disease development.